Hello everyone, this video is for week 9 topic 10 part 2, solving logarithmic equations and inequalities. So this is a preliminary topic which is the loss of logarithms, which can be found on your modules on pages 127 to 133. For the lesson outline, we have the loss of logarithms and change of base formula. So let us start with the loss of logarithms. Let b be greater than 0, which means to say that b is a positive number, but b is not equal to positive 1. And let n be an element of real numbers. We have also u and v are greater than 0, which means to say that u and v are positive numbers. Then we have the first law of logarithm, which is the logarithm of u times v to the base b is equal to the logarithm of u to the base b plus the logarithm of v to the base b. So which simply means that the logarithm of the product of the two positive numbers is just the sum of the logarithm of each of the two positive numbers. Okay, so we have multiplication and addition. For the second law, we have the logarithm of u divided by v to the base b is equal to the logarithm of u to the base b minus the logarithm of v to the base b. So, which simply means that the logarithm of the quotient of the two positive numbers is just equal to the difference of the logarithm of the two positive numbers. So we have quotient, we have difference. Okay, so division and subtraction. And the third law, we have the logarithm of u raised to n to the base b is equal to n times the logarithm of u to the base b. So in this case, in this law, we had take the exponent and we make it as a multiplier of the logarithm of u to the base b. Okay? Now let us have an example of each of the law. Okay, so we have the first law. An example of this is logarithm of 7 cubed times 7 raised to 8 to the base 7 is equal to the logarithm of 7 cubed to the base 7 plus the logarithm of 7 raised to 8 to the base 7. Okay, so we have multiplication, addition. Okay, for the second law, we have the logarithm of 49 to the base 7 or logarithm of 49 over 7 to the base 7 is equal to the logarithm of 49 to the base 7 minus the logarithm of 7 to the base 7. So we have division, subtraction. And the last one, we have the logarithm of 7 raised to 5 to the base 7 is just equal to 5 times the logarithm of 7 to the base 7. So let us explain further the example of each of these loss of logarithms. So for the first law, let us check if the logarithm of 7 cubed times 7 raised to 8 to the base 7 is equal to the logarithm of 7 cubed to the base 7 plus the logarithm of 7 raised to 8 to the base 7. Okay, so we have applying the loss of exponents, we have to add these exponents and copy the base. So we have 3 plus 8 is equal to 11 and copy the base 7. And what do you think is the answer for this? What is the value of this? So if you can still remember the basic properties of logarithms, one of the properties is we have the logarithm of b raised to x to the base b is equal to x. So since we have bases b, the base for the logarithm and the base of the argument are equal, then the answer or the value of that is the exponent of the argument, which is x. So therefore, applying the basic property of logarithm, the answer for this is 11. Okay, so on the other hand, we have this logarithmic expression. Okay, so applying the laws or the basic properties of logarithm. So in this part, the answer for this is 3, which is the exponent of 7. We have the same base for the logarithm and the base of the argument. So the answer is the exponent of the argument, which is 3. And this one, we have the answer, the exponent, 8. So 3 plus 8 is equal to 11. So they are equal. Okay, so the logarithm of 7 cubed times 7 raised to 8 to the base 7 is equal to the logarithm of 7 cubed to the base 7 plus the logarithm of 7 raised to 8 to the base 7. So for the example of the second law, let us check if the logarithm of 49 divided by 7 to the base 7 is equal to the logarithm of 49 to the base 7 minus the logarithm of 7 to the base 7. So let us start with this. So we have 49 divided by 7 is 7. So logarithm of 7 to the base 7. And by applying the basic property of logarithms, so the value of this is 1. So let us check for this logarithmic expression, what would be the value? Okay, so 49 can be expressed as 7 squared, and then copy this. So what do you think is the value of this? Of course, we have the exponent 2, and this one, we have 1. Still applying the basic property of logarithm. So we have 2 minus 1, the answer is 1. So therefore, the logarithm of 49 to the base, the logarithm of 49 divided by 7 to the base 7 is just equal to the logarithm of 49 to the base 7 minus the logarithm of 7 to the base 7. And for the last law, we have the logarithm of 7 raised to 5 to the base 7. So let us find the value. Still applying the basic properties of logarithm. The answer for that is equal to 5. And we have to check that this logarithm of 7 raised to 5 to the base 7 is equal to the logarithm, it's equal to 5 times the logarithm of 7 to the base 7. So applying the one of the basic properties of logarithm, we have 5 times 1 because we have the exponent of 7 is 1. So this is 1. So 5 times 1 is 5. And therefore, these two are equal. Okay? So let us discuss example number 1. Use the properties of logarithms to expand each expression in terms of the logarithms of the factors. Assume each factor is positive. So to answer this, you must be familiar with the concept of these three laws of logarithms. Okay, we will be using the concept of these three laws to answer example number 1 and the rest of the examples. Okay, so let us start. Letter A. We have logarithm of a times b squared. So remember, this is the logarithm of the product of the two numbers. So therefore, applying the first law of logarithms, this is, okay, so we have logarithm of a plus the logarithm of b squared. Okay, so product, we have addition. And if you can observe, the exponent of b is 2. So we can further expand this using the third law. We have the exponent, and therefore the answer for that is the logarithm of a plus 2 times the logarithm of b. So for example A, we have used the first law and the third law. Okay, that is for the first example number 1, letter A. Now let us proceed to letter B. Logarithm of 3 divided by x cubed to the base 3. Okay, so we have quotient and we have still the exponent. So what do you think? Okay, so let us start. So let us start with applying the third law. We have the exponent 3. So we can use this as a multiplier. So we have 3 times the logarithm of 3 over x to the base 3. So this is quotient. So we can have, okay, so we have 3. Since this is quotient, we have the difference of the logarithms of each of the numbers. Okay, so we have 3 times the logarithm of 3 to the base 3 minus the logarithm of x to the base 3. Okay, but this one, we can find the value of this by applying the one of the properties of the logarithms, and the value of this is 1. Okay, the exponent of 3 is 1. So we have 3 times 1 minus the logarithm of x to the base 3. And we can expand this further. We will be distributing 3. Okay, so 3 times 1 is 3. 3 times negative logarithm of x to the base 3 is minus 3 times the logarithm of x to the base 3. Okay, so that is for example 1, letter B. Okay, so we have used the third law for the exponent, and we have used the second law for the quotient of the logarithm of the quotient of the two numbers. And for letter C, we have ln x times x minus 5. So remember, this is product. So kung product, we have addition. So this is equal to ln x plus ln x minus 5. Okay, so these are our first example for the 3 laws of exponents. So for this example, we have learned how to expand each of the given logarithmic expression. Okay, now for example number 2, use the properties of logarithms to condense the expression as a single logarithm. So this is the reverse process for from what we have discussed for example number 1. Okay, so for example number 1, we have expanded. For example number 2, we will be condensing the expression as a single logarithm. So let us start. Letter A, logarithm of 2 plus the logarithm of 3. So we can condense this. So take note, we have addition. It means to say we have the, the logarithm of the product of the two numbers. So therefore, applying the first law, the answer is the logarithm of 2 times 3. So we have 2 times 3 is equal to 6. So we have the final answer, logarithm of 6. Now let us proceed to letter B, 2 ln x minus ln y. So we have here 2. So it means to say that the exponent of x is 2. Okay, and we have this subtraction. It means to say that this is the quotient of the logarithm, or the logarithm of the quotient of the two numbers. So this is equal to what? So we have ln x squared minus ln y. So since this is the difference, or the logarithm of the difference of the two numbers, we can further condense this as ln x squared divided by y. Okay, that is for example number 2, letter B. Okay, so we have used the third law and the second law. And for letter C, we have logarithm of x squared to the base 3 minus 3 times the logarithm of x to the base 3. So what do you think are the laws that we need in order for this to be condensed as a single logarithm? Okay, so we have, okay, so your 3, it means to say that this 3 is the exponent of x. So we have the logarithm of x squared to the base 3 minus the logarithm of x cubed to the base 3. So 3 is the exponent of x. Okay, next, what do you think is our next step? So since this is subtraction, it means to say that this can be further condensed as the logarithm of the quotient of the two numbers. So therefore, we have the logarithm of x squared divided by x cubed. Okay, and then since we have the same basis, we can then subtract the exponent. We can further simplify this. Okay, so we have 1 over x. We subtract the exponent. Okay, or we can use cancellation. Okay, so we can cancel 2. We have 3. What is left is x. So we have 1 over x. And further, we can simplify this as applying the laws of exponent. The exponent of x is positive 1. If we will be expressing this with a negative exponent, this is x raised to negative 1. Okay, and therefore, since the exponent of x is negative 1, applying the third law, we can have your negative 1 can be the multiplier. Okay, so this will be equal to negative 1, or negative logarithm of x to the base 3. Okay, next example, we have letter D, 2 minus the logarithm of 5. Okay, so how can we express this as a single logarithm? Okay, so remember this is 2, and the other part is a logarithmic expression. Okay, so first we'll be expressing 2 as a logarithm of a number to the base 10. So remember, this is common logarithm. And a common logarithm, we have the base 10. So it is not written, it is understood that the base of this is 10. So we will be expressing 2 as a logarithm of number to the base 10. So your 2 can be expressed as, of course, we will be using the basic properties of logarithm. You are familiar of this. We have we have used this several times in the previous example. So how would we express 2 as a logarithm of a number to the base 10? Okay, so we can express 2 as logarithm of 10 squared to the base 10. Okay, so remember the base of this is 10. The base of the argument is 10. Therefore, the value of this logarithmic expression is 2. Okay, by applying this basic property of logarithm. So again, we have expressed 2 as the logarithm of a number to the base 10. So we have now this logarithmic expression which is equivalent to 2. And therefore, expanding this will become logarithm of 100. So 10 squared is 100. So this is now our 2. And therefore, we can use this, we can substitute this to 2. So therefore, your 2, we can substitute logarithm of 100 to 2. So logarithm of 100 minus the logarithm of 5. So now we can condense this because we have the difference of the two logarithms. Okay, we have the same base, which is 10. And since this is a difference, we can condense this as the logarithm of 100 divided by 5. Okay, and simplifying further, we have the logarithm of 20. Okay, so for example number 2, we have the given logarithmic expression. We have condensed the given logarithmic expression into a single logarithm. Now let us proceed to the next topic. We have change of base formula. So let a, b, and x be positive real numbers with a not equal to 1 and b not equal to 1. Okay? So according to change of base formula, logarithm of x to the base b is equal to the logarithm of x to the base a divided by logarithm of b to the base a. Okay, so remember your a must not be equal to 1, and we have the x, which is the argument, and b, which is the base of your logarithm. So this is what we call change of base formula. Okay, from the base b, we have changed our base to base a. Okay, to discuss further, we will be discussing some of the examples of this. Okay, let us now discuss example number 3. Use the change of base formula to rewrite the following logarithmic expression to the indicated base and then compute the value. Okay, so let us start. Letter A, logarithm of 32 to the base 8. You are asked to change to base 2. Okay, so this is our change of base formula. So what do you think is the answer for letter A? How would we change the base using the change of base formula? Okay, so this is equal to logarithm of 32 to the base 2, because you are asked to change to base 2, over the logarithm of 8 to the base 2. Okay, so but you are asked to find or compute the value. So we'll be solving for the value of this. Okay, so your 32 can be expressed as 2 raised to 5. Okay, and 8 can be expressed as 2 cubed. Okay, so this is 32. 2 raised to 5 is 32, and 2 cubed is 8. So what do you think is the value of this? Again, we will be using one of the basic properties of logarithms. So we have the same base, 2, and therefore the answer for this is the exponent of the argument. So we have the exponent 5 and we have the exponent 3. So therefore for letter A, the value is 5/3. Okay? Let us proceed to letter B, logarithm of 1 over 27 to the base 243. You are asked to change to base 3. Okay? So applying the formula, to change the base formula, we have logarithm of 1 over 27 to the base 3 over logarithm of 243 to the base 3. So we will be expressing 1 over 27 so that we can have the base 3, and also for 243 so that we can have also our base 3. Okay? So therefore 1 over 27 can be expressed as 3 raised to negative 3, and 243 can be expressed as 3 raised to 5. Okay, and still applying the one of the basic properties of logarithm. This is equal to, okay, the exponent is negative 3. The exponent of 3 in the denominator is 5. So negative 3 divided by 5 is negative 3/5. So this is the value for example number 3, letter B. And for letter C, we have the logarithm of 1 over square root of 5 to the base 25. Okay, so applying the change of base formula, so we have this expression. Okay, so we'll be expressing 1 over square root of 5 so that we can have the base of 5, so that we can get the value of that by applying the basic properties of logarithm. And also 25, we will be expressing 25 so that we can have a base of 5. And therefore 1 over square root of 5 can be expressed as 5 raised to negative 1/2. So if you can still remember, your radical expression can be expressed as a number with a rational exponent. So square root of 5 can be expressed as 5 raised to 1/2. Okay, so 5 raised to 1/2, we will be expressing that 1 over 5 raised to 1/2, we will be expressing that so that our base is 5. So we can have 5 raised to negative 1/2. So we applied the law of exponent. So your positive 1/2 in the denominator as the exponent became negative. Okay, and in the denominator, your 25 can be expressed as 5 squared. And applying the basic property of one of the basic properties of logarithm, the exponent, we have negative 1/2. We have also the exponent 2, and further by simplifying this, we have negative 1/4. So negative 1/2 divided by 2, we will get the reciprocal of 2, which is 2 over 1, and then multiply it to the numerator. So negative 1/2 times the reciprocal of 2, which is 1/2. So negative 1/2 times 1/2 is equal to negative 1/4. Okay, so this is the value for example number 3, letter C. Now let us discuss example number 4. Use the change of base formula to rewrite the following logarithmic expressions to the indicated base, and then simplify. Okay, so let us start with letter A. Logarithm of 4 to the base 6. You are asked to change to base 2. Okay, so applying the formula, of course, we have logarithm of 4 to the base 2 divided by logarithm of 6 to the base 2. Okay? So your 4 can be expressed as 2 squared. But your 6, you cannot find any ways so that we can express this as a number with a base of 2. So therefore, we can have logarithm of 2 squared to the base 2 over logarithm of 6 to the base 2, and we can find the value of the numerator. Okay, and that value is 2. So we have 2 over logarithm of 6 to the base 2. So this is our final answer. For letter B, logarithm of 2 to the base 1/2, you are asked to change to base e. Okay, so applying the change of base formula, we have logarithm of 2 to the base e divided by logarithm of 1/2 to the base e. Okay, so remember that this logarithm of 2 to the base e can be also written as ln 2, and the denominator logarithm of 1/2 to the base e can also be written as ln 1/2. Okay, and therefore by applying one of the laws of logarithms, we have the quotient. So for the denominator 1/2, we can further expand this as, okay, so we have ln 2 divided by ln 1 minus ln 2. Okay, so for the denominator, this is quotient, so therefore we have the difference, the logarithm of the difference of the two numbers. Okay, and then by applying the first basic property of logarithm, which is logarithm of 1 to the base b, which is equal to 0, so it means to say this part is equal to 0. So we can have ln 2 divided by negative ln 2, and therefore the quotient of these, they are just the same, but the denominator is negative. Therefore the final answer is negative 1. Okay, that is for example number 4. So for this video, we have discussed the 3 laws of logarithms. We have also discussed expanding the given logarithmic expression, and we have also discussed how to condense the given logarithm into a single logarithm. Okay, so always remember these 3 laws of logarithms, because we will be using these 3 laws, including the 3 basic properties of logarithms and the change of base formula in our future discussion of solving logarithmic equations and inequalities. So that's all. Thank you very much.